Hello everyone. So I have another helpful tutorial here for you all, and this is on constant rate of change again, but this is a different question. So this is question from homework 2.1, number 8. Okay? So the first thing that I want to just point out is that when you're given a table and it states that this table has the values for a linear function, remember, linear functions consist of a mathematical relationship whereas the values of x and y vary together, there exists a constant rate of change, right? So I'm going to put it in a different color. So I'm going to put it in purple. Constant rate of change. So when you see this form of constant rate of change, I want you to think about what is this statement saying, okay? So to me, it's saying that where the change in the numerator, now the reason why I'm saying numerator is because what if you get a problem where it's not x and y and it says s and k or any other variables, all right? And you could still hold this same relationship. It does not have to be x and y, okay? So where the change in the numerator, y, is m times as large as the change in the denominator, which is x, okay? Now, the reason why I'm using this type of language, okay, is because take a step back, all right? So when you see the ratio 6 divided by 2, you get 3, right? And so you can say that 6 is 3 times as large as 2, okay? That's the same thing that I'm saying in the statement that I just made. The change in y is m times as large as the change in x, okay? So now, with this problem, again, as well, okay, I'm going to continue in purple because these are notes. These are ways of thinking that I want you to have while doing problems like this, okay? We can rewrite this problem where what if I multiply delta x, the change in x, on both sides, okay? If I did that, I'd basically cancel out these two, and I would be left with change in y equals m times change in x. So please understand that there's no real difference between the two of these. It's still saying the same thing. Whatever the change in y is, the change in y is going to be m times as large as the change in x. Okay? We just rewrote it. But please also understand that this relationship must be the same, must be true, okay? It must be true for all the values, okay? So it must be true for all values in this table, for this problem, okay? So now let's take this for instance, okay? So going from x from -2 to 14, okay? I want you guys to notice or think to yourself, what is the change in x, okay? And just as a quick little side note, if you forgot, remember delta x, you're talking about one x value from the other. You're taking the difference between two values, okay? This is why you normally see y equals y2 minus y1 over x2 minus x1, which is just delta y over delta x, okay? But I'm going to write that down a little bit in a second, okay? And then I also want to think about what is the change in y, okay? So these are two things that I want to think about, all right? So With this being said, I'm going to make this a little bit smaller. Okay. So I have a little bit more room. All right. So let's do this. Let's take, okay, -2, 7 and 14, 71. Okay. So what is the constant rate of change? Okay. Well, when you're trying to figure out what's the constant rate of change, we usually have this formula, right? M equals delta y over delta x. Or remember, like I said, y2 minus y1. And let me zoom in for you guys, okay? Divided by x2 minus x1. So remember, you can use, so I could do this one as x1, y1, x2, y2. Okay? And we will get, so we could do 71 minus 7 over 14 minus -2. When we get that, we get 64 divided by 16, and then we will get 4. So this is what I'm saying, okay? Thus, m equals 4. So this is telling me, okay? So this means for any change in x, and my handwriting is pretty bad, so please bear with me. Any change in x, the change in y is 4 times as large. And so this is very, very helpful. So you're going to see why this is so helpful, this key part right here. Okay? So now, remember the whole end game of this problem, all right? So let me scroll back up, is that we are now trying to figure out what is A, okay? What is A? And so because of that, we're going to use this same idea that I just stated, okay? Because if this is a linear relationship, then that means that little part that I had at the bottom, okay? Whatever your change in x is, your change in y is going to be that many times as large, and that is that constant rate of change, okay? So let's notice this, okay? So when x increases from -2 to 10, my change in x, okay, is 12, all right? And what is my change in y, you say? Well, I don't know exactly just yet, but what I do know, okay, is that whatever my change in y is, it has to be 4 times as large as the change in x. All right? So these are two of the biggest things that I want you guys to understand. Now, let me scroll back down and I'm going to write this information, okay? So like I said, so for -2, 7 and 10, a, x changes from -2 to 10. So that means that delta x equals 10 minus -2. Okay, reason why I'm doing that, remember why? Because remember earlier I said delta x equals x2 minus x1. Okay, that's a way for you to find the change. It's always final minus initial. So I always like to also put it like this. Final minus initial. So you always get that. All right, and so then we'll get 12, okay? And so then remember I told you that delta y equals 4 times delta x. So let's plug that in. So we have delta y equals 4 times 12, because that's our change. And now we're stating that delta y equals 48. How is that useful, you guys? How is that useful? So, yes, I'm doing a lot of scrolling because I can't bring that down. So, this is now telling me, okay, that if my change in x is, oopsie, if my change in x is 12, right? Remember, we got now delta y, okay? Delta y is 48. So our final answer A is 48 plus what? And is 48 plus that 7. Which will get us 55.